Did you know that still we don't really know how transformer models work behind the scene? We roughly know what happens within that neural network, how it starts from its input layer and how it gives output. But when we try to get into the nitty gritty of these neural networks, there are a lot of gray areas. That is why whenever a visualization tool comes in, which gives us a bit more clues as how exactly this whole process works, I am always very much excited to test it out. On your screen, you can see this new tool called as LLM Visualization, which gives you a peek into the inner workings of LLMs. It's not detailed, but still it gives you an overview of how these LLMs work. Unless you are looking to create a model from scratch, I think we all should have at least a high level overview of how transformer models work. When we say transformer is a type of neural network architecture which was introduced around 2017 for natural language processing tasks. It's primarily designed to handle sequential input data like text or time series data. The transformer's core innovation is its ability to efficiently process input sequence in parallel, making it faster and more scalable than traditional recurrent neural network or RNNs. One of the key feature or salient feature of transformers is self-attention. Self-attention is a key component here. It's a mechanism that allows the model to focus on relationships between different parts of the input sequence. Self-attention computes attention weights based on the similarity between each token's embedding and every other token's embedding. Embedding is simply a numerical representation of any of the token. A token could be a word or a character. That enables the model to capture complex dependencies within the input data. Now, let's try to see what is happening here. So we have selected Nano GPT from here. You can go with GPT-2 small, GPT-2 XL, GPT-3. All generative pre-trained transformer are the same. So we'll just go with Nano GPT here. Now, in order to visualize what we are trying to do here, we are trying to pick up this sequence of characters and we are trying to sort them something like ABBC. So let's suppose this has been fed into the model as an input, then we are going to see how exactly it works. So this is a sequence of letters, right? So first up, when we click on continue, what is happening here is that we are creating the tokens, which are the individual units of the input sequence. In this case, each letter is a token. So the CBA, BBC become a different token with a numerical representation because of course LLM is a software only understands a number. Once that's done, then comes the embeddings, which is simply a numerical vector that the model can understand. Each token is mapped to a unique vector. Think of it like a dictionary where each word letter has a corresponding vector. Now, then comes this is telling you that green cell is number being processed and each blue cell will be the weight, and we will shortly see it in the progress. So then the embedding is passing through the model as you can see here. And then now what is happening here is that is using layer norm or normalization. So layer norm has stabilized the embeddings by normalizing them to have a mean of 0 and a standard deviation of 1. This helps with training stability and prevents exploding gradients. Gradients is just a measure of loss as how much is the model is deviating from the expected value. Self-attention, we already know what that is, and you see this is where embedding is passing, and then what is happening is that it is projecting, which is transforming the output of self-attention into a high dimension space. This helps the model capture more complex relationships. And then it is going through multi-layer perceptron or MLP, which is a feed-forward neural network that processes the projected output. It consists of multiple layers, allowing the model to learn non-linear relationships. And then it is going through the transformer, which is a core component comprising self-attention, projection, and MLP. It's applied multiple times, as you just saw, to process the input sequence. Then we have Softmax and then Logits, as you saw. Softmax is simply an activation function that converts the output of the transformer into probabilities. For each position in the sequence, it predicts the probability of each letter being the correct choice. And then you also have seen something called as logits. And I will quickly show you once this is done. You see, there you go. So these are the embeddings. Again, this is, it is calculating. And there you go. It is just applying the layer norm here. And then again, after layer norm, it is going through, and there could be multiple layer. And these are some numerical representations which are happening. And then here we are just going through the layer norm and other stuff. And logits are the raw unnormalized scores produced by the Softmax function, by the way. And they represent the model's confidence in each letter being the correct choice. And then that logit, which is the raw probability, is converted into output, and that's pretty much it. So similarly, you can just click on this GP2 small here, and then it is going to show you how it works. And of course, Nano GPT is the basic one. And as you progress, say GPT-2, GPT-2 XL, GPT-3, it is going to become more and more complex. So if I go at the top, select GPT-3 here, and then continue, you will see the same thing happening, but with a different architecture, with more complex nuances and stuff. But underlying process is same in everyone. As long as you understand these concepts of MLP, of these self-attention, transformers, logits, there shouldn't be any issue. Also, I already have covered various other LLM visualization tools. If you're interested, just go to my channel and search with it. So if you just go to the channel, just click on the search, just type visualization, and you will see that this is the tool which I did around 4 months ago. This is also pretty nice, very similar. You can check it out. And then there are a few other tools which I have covered in great detail. So if you're interested in this high level stuff, I would highly suggest them. Also, I have done various videos around LLM architecture, transformer architecture. We have also looked at various research projects. So if you're keen, feel free to search it out. Also, I would highly be grateful and indebted if you subscribe to the channel. If you're already subscribed, then please do me a favor, share it among your network, as it helps a lot to grow the channel. Plus, I would highly request you to share the videos and stuff on the various social media platforms, especially on Reddit or X or Twitter or Facebook, wherever you like. So that's it, guys. I hope this was useful. Thanks for watching.